Video we're going to be looking at exponential equations leading to simultaneous equations. Taking the example, find the value of x and y given x plus 6y equal to 3 and 2 raised to the power x plus y equal to 1 over 4. Solving these, we have to first do the calibration for our equations. So we have x plus 6y equal to 3 from the equation as equation 1, and then our second equation is going to be derived from this exponential equation. We have to first reduce the exponential equation to a linear equation. So let me write it down here. We have 2 raised to the power x plus y equal to 1 over 4. Right, note this exponential equation could be written as 2 raised to the power x plus y equal to 1 all over 2 raised to the power 2. Right, you see the 2 raised to the power 2 means 2 multiplying by itself 2 times, and 2 times 2 is going to give us this 4, right? So actually there's no changes, and from this we can write this statement or this equation: x plus y equal to, instead of 1 over 2 raised to the power 2, you can write it as 2 raised to the power minus 2. From indices 1 all over a raised to the power m is going to give us a raised to the power minus m, right? So if we're taking that a lot of indices, then we're going to have our 1 over 2 raised to the power 2 written as 2 raised to the power minus 2. And also, in solving exponential equations, it is known that when the exponents of the bases, when the bases are equal, then we can equate the exponents of the exponential equation. So looking at this exponential equation, considering the left hand side, we have the base to be 2, and then considering the right hand side, we have the base to be 2. Then since the bases are the same, we can say that x plus y is equal to minus 2, right? So we're going to equate our exponents. X plus y equal to minus 2, right? Then that's going to be our equation 2. Equation 2, not 3. Equation 2. Right, now that we have our equation 1 and equation 2, we can solve them simultaneously. We can use the elimination method, substitution method, or the graphical method in solving simultaneous equations. But in this, we're going to use the mixture of substitution and elimination. So first, what we're going to do is that we're going to subtract equation 2 from equation 1. So we have equation 1 minus equation 2, right? And then having that, we going to write our equation 1 as x. Am I right? I think there's something wrong somewhere. Yes, look, let me subtract this. Give me 5. Oh, okay, it's right. Then I need to start over my video. Okay. 6 minutes wasted. Wow. Let's go. You see, I want you just 5 minutes to solve this. Can't I solve this? Okay, right. Go. Right. In this video, we're going to look at exponential equations leading to simultaneous equations. Taking the example, find the values of x and y given x plus 6y equal to 3 and 2 raised to the power x plus y equal to 1 over 4. To solve these, we need to first calibrate our equations. So we're going to have x plus 6y equal to 3 as our equation 1. And then for the equation 2, you see this is an exponential equation, right? So we have to first reduce the exponential equation to a linear equation. So let me write it here. We have 2 raised to the power x plus y equal to 1 all over 4. Okay, now this exponential equation could be written as 2 raised to the power x plus y equal to 1 all over 2 raised to the power 2. You know, 2 raised to the power 2 means multiply 2 by itself 2 times, and 2 times 2 is going to give you this 4. So this is actually the same as what we have here, right? Cool. Then also from indices, we do know that if I have 1 all over a, it could be written as a raised to the power minus 1, right? Or if I have 1 all over a raised to the power m, this could be written as a raised to the power minus m. Okay, so because of that, we want to rewrite this 1 all over 2 raised to the power 2 in that format, right? So let us rewrite it. 2x 2 raised to the power x plus y is going to be equal to 2, so 2 raised to the power negative 2. And from exponential equations, when the bases of your exponential equations are the same, then we can equate the exponents of the exponential equation. That is, the base to the left hand side is 2 and the base to the right hand side is 2. The bases are the same, so we can say x plus y is equal to minus 2. Let's write that down. X plus y is equal to minus 2. Now it's going to be our equation 2. See, we have reduced the exponential equation 2 raised to the power x plus y equal to 1 over 4 to 2x plus y equal to minus 2. So that's our equation 1, x plus 6y equal to 3, and then our equation 2, x plus y equal to minus 2. Now we're going to solve them simultaneously, and solving them simultaneously, we can decide to use substitution method, elimination method, or the graphical method. But in this video we're going to use the mixture of the substitution and the elimination. So let us use the elimination method here, and in the elimination method I'm going to be subtracting the equation 2 from equation 1. So I will have equation 1 minus equation 2, right? So my equation 1 is x plus 6y equal to 3. My equation 2 is x plus y equal to negative 2, right? So I'm going to be subtracting the equation 1, equation 2, subtracting equation 2 from equation 1. Okay, now let's do the subtraction. 3 minus negative 2, so that's going to be 3 minus 2, and negative is gonna turn to what? Positive. and 3 plus 2 is going to give us what? 5. So actually 3 minus negative 2 is going to be 5, equal to 6y minus y is going to give us 5y, and then x minus x is going to give us 0, right? So from here we can solve for the value of y. 5y is equal to 5. So we divide both sides by the coefficient of y, which is 5, right? So 5y all over 5 is equal to 5 all over 5. Then our y will be equal to what? 1. Okay, 1. Now that we're done getting the value for y, then we need a value for x, right? Now to get a value for x, we can do substitution. That is what I was talking about. You want to use a mixture of substitution and elimination. We're going to put y is equal to 1 into any of the equations that we had, but I prefer to put it into equation 2, right? So we're going to have into equation 2. What's equation 2? Equation 2 is x plus y equal to minus 2, right? So if I put 1 in place of y, we're going to have x plus 1 equal to minus 2. So I want the x to stand alone, or I want to make x the subject. I'll need to send this one across the equality sign. The 1 is positive. When it crosses the equality sign, the positive sign changes to negative, right? So we're going to have negative 1, and then x will be equal to minus 2 minus 1. That will give us minus 3. Okay, so therefore we're done solving our equation. We can say that therefore x is equal to minus 3 and y is equal to 1. Thank you.